Okay, well, so much for that great plan. Google Classroom is just showing me a blank screen, whirring. So I'll record them instead. So today we're focusing on the topics we've covered on number and also part of the algebra. So I split the algebra up into three parts because we've done a lot of algebra. So number, write down 0.4, 15% and 7/20ths in ascending order. So in order to do that, you need to have them all in the same format. 0.4, you could write a 0.40, and that would give you that in sort of stayed in decimal, but I've given it 2 decimal places so that I can compare it with 15%, which I can write as 0.15. So those are straightforward. The more complicated one is 7/20. Now I can write that as a percentage if I have it out of 100. So to turn it into 100, to turn the 20 into 100, I have to multiply by 5, which means I also have to multiply the top by 5. 7 5s are 35. So that's 35 out of 100, which is 35%, or 0.35 as a decimal. So now that I've got them all in decimal, I've written that to 2 decimal places, so I've got a direct comparison. I can see the smallest value is 0.15, which is 15%. 0.35 is next, which is 7/20, and then finally 0.4 is the largest. So the key thing you need to practice with that is getting them all into the same format, and you need to show that working out. You can't just guess, you won't get any marks. Express 700 as a product of its prime factors in index form. This is where we repeatedly divide the number by a prime number until we end up with just primes left. So it's an even number, so the easiest prime number to divide by is 2, which gives me 350. That's not prime. It's even, so I can divide by 2, and I get 100 and what do I get? 175. I'll just check that in case I go brain dead. Yeah, 175. 2 doesn't go into 175, but it ends in a 5, so it's definitely not a prime number because 5 will divide into it. 175 divided by 5 is 35. 35 isn't a prime number because 5 goes into it. 5 goes into it 7 times. Now 7 is a prime number, so I can stop. I've broken that down now into those. The question wants it in index form. So 700 is the same as 2 times 2 times 5 times 5 times 7. That's not in index form. Index form is where you write it to the power. So 2 times 2 is the same as 2 squared. 5 times 5 is 5 squared, and times 7. And you can put a little power up there of a power 1. You don't need to. If you just left it as 7, that would be fine. But if the question then asked you what you would have to do to make the number square, you'd need to make that positive, even, sorry, so you would need to multiply by another 7. And it's easier to see that if you have the 1 there. So part B, that big number is equal to 2 to the power of 25. Explain how this tells you that that number is not a square number. Well, it's as I mentioned up there, because it has an odd power. If it's a square number, all the powers would be even. So as I said, that's not a square number because we've got an odd power that's one of the prime factors is being multiplied by. Question 3. Okay, so this is like a puzzle. You're solving a puzzle to find a number. A whole number is written on a card, so it's whole. So it's 1, 2, 3, 4, that sort of number. You were given 3 clues to help you work out the number on the card. Clue 1, double the number is between 8 and 18 inclusive. So if double the number is between 8 and 18, then the number is going to be half of those. So number between half and 9. Inclusive means it could be 4 or it could be 9. So my answer is either 4, 5, 6, 7, 8 or 9, because those are whole numbers, and when I double them I get the numbers between 8 and 18. The number is a prime number, so it's not 4, it's not 6, it's not 8, and it's not 9, because those all have factors other than themselves and 1. And the number is not a factor of 100, which means it doesn't divide exactly into 100. So the number has to be 7. It's the only one that satisfies all 3 of those clues. If I double it, it's between 8 and 18. It's a prime number, and it doesn't divide exactly into 100. Calculate the answer when the largest prime number that is a factor of 28 is multiplied by the smallest prime number that is a factor of 15. So factors of 28, if you remember, I always encourage you to list them as factor pairs. So 1 times 28 is 28. 2 times 14 is 28. 3 doesn't go into 28. 4 goes into it 7 times. 5 doesn't go into it. 6 doesn't go into it. And then we're back then to 7 and 4, which means we're repeating. So those are the factors of 28, and the largest of them that is prime, that's prime, that's not, that is, that's not, that is, that's not, that's not. So the largest prime number there is 7. Then we do the same for 15. So 15, we got 1 and 15. 2 doesn't go into 15. 3 goes into it 5 times. 4 doesn't, and then we're back to that. So we're repeating. The smallest prime there is 3. So calculate the answer when the largest prime number that is a factor of 28, that's 7, is multiplied by the smallest prime number that is a factor of 3. We get 21. Question 5 is a calculator question where we need to round our answer. So we can type this onto our calculator exactly as we see it. Square root button. 8.5 cubed, there's the cube button, plus open bracket 4.5 minus 0.76 close bracket, oops, squared button. So there we are, so we've typed it in. That gives us this answer. So I'm going to write down what's on my screen. Showing that I've got the right thing out of the calculator. So I've guaranteed 1 mark now, and then to get 3 significant figures, your significant figures you start counting immediately. The 2 is the first, it's the most significant because it stands for 2 lots of 10. It's in the tens column, so it's worth 20. That's the next most significant, and then that's the third. So the 3 most significant are either going to be 25.0 or 25.1. To decide which, we look at the next. It's 5 or more, so that's going to round up to 25.1 to 3 sig fig. Reciprocal means 1 over. So what I'm actually going to do on my calculator is that. You can type it in exactly as I see it using the fraction button. 1 on the top, negative 0.07 underneath. So that works out to be minus 14.2857149. Got one mark, and then to round it to one decimal place, the first decimal number after the decimal point is a 2, but it rounds up because we look at the next one along. So that's going to be minus 14.3 to 1 dp. Question 6. Find the answer of the following number problem. So this time we're looking for lowest common multiples. This one's likely to be on a paper 2, but it could be on a paper 1. So the lowest common multiple, so multiples are what you get in your times tables. So the 12 times table goes 12, 24 and so on. Best way to start is with the larger one. So we've got 24, then we've got 48, and what we want to do is to see if 18 will divide into 48. It won't. So I'll do 3 lots of 24. 3 lots of 24 is 72. Will 18 divide into 72? It will. Will 12 divide into 72? It will. So the smallest number that is in the 12, 18 and 24 times table is 72. Then we want to work out the highest common factors. So we did the common factors in the previous question. So with 36, I've got 1 and 36, I've got 2 and 18, I've got 3 and 12, I've got 4 and 9, 5 doesn't, 6 sixes. So once I get the 6 sixes, they're going to repeat after that. So the highest common factor of 36, well, those are the factors of 36, and then 54 will be 1 and 52, 2 and 27. Does 3 go into 54? Yes, 18 times. Does 4 go into 54? No. 5 doesn't. 6 does. 9 times. 54 divided by 7, 54 divided by 8, and then we're back to 9. So the highest common factor of 36 and 54 is the biggest number that's in both of those groups, which is 18. So the LCM is 72, the highest common factor is 18, and what they want us to do is the LCM divided by the highest common factor. So we're going to do 72 divided by 18, which gives us 4. Number 7. A rectangular rugby pitch has a width of 74 metres measured to the next metre. To the nearest metre, sorry. Write down the upper bound of the width of the pitch. So if things are being measured to the nearest metre, their measurements are going to be whole numbers. So I'm going to have sort of 70, 71, 72, 73, 74, 75, 76 and so on. Now mine is 74 measured to the nearest metre, so it's been rounded to 74. So the upper and lower bound, the lower bound is halfway between 73 and 74, and the upper bound, so that's the lower, and the upper will be halfway between 74 and 75, which would be 74.5. So the upper bound is 74.5 metres. The length of the pitch is 115 metres measured to the nearest 5 metres. So if things are being measured to the nearest 5, then they're going to be counting up in 5. So it'll be 105, 110, 115, 120, 125, and so on. Ours is 115, so the upper and lower bounds, it's the lower bound, this is the upper bound, will be halfway between these. So that's going to be at 112.5 and 117.5. We want the upper bound, so it's going to be 117.5. So whatever the rounding accuracy is, that tells you what sort of numbers can be written. You're not going to have a number of 108 because it's going to be rounded to the nearest 5. So write down your numbers that could be your answer and then work out the dividing bit halfway between them. So those are all the number topics we practiced this term. So now we're on to the first chunk of algebra where I'm focusing on simplifying. So simplifying this expression. When we practiced this, what I said to you was if you think that each part of an expression has 3 bits to it. It's got its sign, which tells you whether it's positive or negative. It's got its size, tells you how big it is. And it's got its variable, it's got its letter. So that there is negative 5f. And we can combine that with any other f-only terms. So here, sign is positive, size is 3, variable is f. So that's telling me on my number line, I start at -5 and I'm adding 3 to it, which takes me to -2. So I'm going to have a -2f. Then I've got -3g and I've got 10g. Now I'm missing a sign there, which means it's positive. So I've got +10, I'm going down 3, I end up at +7g. You don't need to put that plus in, but you do need to have that minus in. When you're factorizing, you want to put things into brackets. It's the opposite of multiplying out brackets. So you're looking to see what's common to both parts of that. Well, I know that 6 goes into 12, so I can take a 6 out. And I can see here that I've got x squared, which is the same as x times x, and there I've got an x. So there's an x term I can take out as well. If I knock that out of there and out of there, I'm left with 6 goes into 6 once, x goes into x squared, leave an x. And then for the second part, 6 goes into 12 twice, x goes into x, leaving no more x's. You can always check it by multiplying back out. 6x times x, 6x squared, 6x times 2, 12x. Circle the correct answer for each of the following. Well, x cubed means x times x times x. And x to the 6 means you're multiplying that by itself 6 times. Times x times x times x times x times x times x. So what you end up with is multiplying x by itself 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So it's x to the power of 9. So the way you remember that when you would have practiced it back in year 10 is if the bases are the same, if the bottoms are the same, they're both x, then you add their powers when you multiply. With this, we can get rid of the brackets. 7x minus 5y. This is just like a 1 outside there. So it's going to be 1 times 7 is 7x. 1 times minus 5y. But here, that's like minus 1. So what you have to remember is that that minus multiplies in. And when the signs are different, that's positive, the answer becomes negative. So that becomes minus 3x. And that becomes minus 2y. 7x minus 3x is 4x minus 5y, taking off another 2 takes you to minus 7y. And then the last couple, factorising here again. This time I haven't got a number I can take out as a common factor, but I can take out an x, because what I've got there is x times x times x minus 5x. So I can take out an x, and that's going to leave me xx, which is x squared, minus 5. Check it. X times x squared is x cubed. X times minus 5 is minus 5x. When you have double brackets, you have to multiply everything in the first bracket by each and every term in the second. So I've got to do the 2x times the x, which will give me 2x squared. Then that 2x has to be multiplied by the 4 as well, which will give me plus, because that's positive and that's positive. 2 times 4 is 8x. So I finished with the 2x now. So now I'm dealing with the minus 3. I'm multiplying, so I'm doing 3 times x is 3x, minus times a plus, signs are different, answer's negative. 3 times 4 is 12, minus times a plus, signs are different, answer's negative. Then I can simplify that further because I've got two x terms. I can't do anything else with the x squared because I would need other x squareds. But plus 8x, take away 3x is plus 5x, take away 12. And then the final grade B skill that we practiced was if you've got a quadratic expression, or a quadratic expression is where you've got an x squared term, an x and a number, just like we did there. That means that when we factorize that, I end up with double brackets. We're basically reversing what we've done in part B. And the method you have to remember, learn, is first of all you list the factors of 28. So we've got 1 and 28, we've got 2 and 14, 3 doesn't go into it, 4 does 7 times, 5 doesn't, 6 doesn't, 7, and then we're back to the start. So those are my factor pairs, which means one of those pairs of numbers, sorry, inside the bracket you always put the XX. One of those pairs of numbers are going to drop into there. And to decide which, you have to figure which possible combination of those numbers could add to make negative 3. There's no way 1 and 28 can make negative 3. There's no way 2 and 14 can, but 4 and 7 can. If I added them, I'd get 11. If I took 7 take away 4, I'd get 3. If I did 4 take away 7, I get minus 3, and that's what I want. So 4 take away 7 means I'm looking for that. So when we do solving equations tomorrow, we'll take a look at another one of those where the next step is to solve a quadratic equation. But for today, we just needed to practice that. Okay, so hopefully you did all right with those. Hopefully Google Classroom will work tomorrow morning, and I'll get a chance to have a chat with you about them.